Hello everyone, welcome back to my YouTube channel. In this particular video, we'll be looking into Karl Pearson's coefficient of correlation. Now, if you remember in the previous video, we already have seen correlation and multiple types of correlation. Correlation is a measure through which we can understand the relationship among two variables. So, Karl Pearson's coefficient of correlation is one of the way through which we can get the correlation measure, and from that particular measure, we can understand how those two particular variables are correlated. Here we have taken two variables in our problem, x and y. Both these variables have five data instances, five data points. From this particular data, we are going to study the relationship among these two variables. So there is a particular formula through which we can get the correlation coefficient from this particular method. And the formula goes something like this. Correlation coefficient, that is denoted by R. Here it is given by small n, that is the total number of data instances that we have in our data set, multiplied by summation of xy. This is the summation of dot product of both the variables, minus summation x dot product summation y. The whole divided by square root of small n multiplied by summation of x square minus summation x the whole square multiplied by square root of small n multiplied by summation y square minus summation y the whole square. Now there are a lot of terms that we are yet to find to plug in those values in this particular formula. So one by one, let's try to find out these particular values of all these terms, starting with small n. So over here in our data set, we can clearly see that we have five data points. 1, 2, 3, 4, 5. So we can say we have n value as 5. So we got our n value. Now we have x and y. We have to find out the sum of these two terms because we will require it in our formula. Summation x and summation y. So let's try to add all these values. We will simply get 5 plus 8 plus 10 plus 12 plus 7. It gives rise to 42. Similarly, summation y is nothing but 7 plus 10 plus 11 plus 10 plus 9. It gives rise to 47. Now, according to the formula, we'll also require more three terms, that is x square. See, in the formula, we'll require summation x square. So for that, we'll have to find out the squared values of each and every data instance of x. Focus on this x variable. Here, visit each term and square it. 5 square is 25, 8 square is 64, 10 square is 100, 12 square is 144, and 7 square is 49. Now, we'll require the summation of all this. And the sum of 25, 64, 100, 144, and 49 is nothing but 382. So we got our summation x square. Similarly, we'll also require summation y square. For that, we'll have to find out the squared values of y term. So 7 square is 49, 10 square is 100, 11 square is 121, 10 square is 100 again, and 9 square is 81. Now, the summation of all these terms is nothing but 451. So, we got summation y square. Now, along with summation x square and summation y square, we'll also require summation xy. Do you want to check out this attractive funny memes? Then what are you waiting for? These are just a glimpse of the memes that I've created on my Instagram page. You can find the link to my Instagram handle in the description box. Please visit the link and do watch all these interesting funny memes. These are not just memes. These memes and reels contains technical information. Here I try to relate memes with the technological concepts. So please do appreciate that by watching all those. And if you love it, please hit the follow button. And for finding out summation xy, first we'll have to find out the multiplication of x and y variables for each and every term. So for finding out the xy for the first data instances, here we can simply multiply them. 5 multiplied by 7 is nothing but 35. Similarly, 8 multiplied by 10 is nothing but 80. 10 multiplied by 11 is 110. 12 multiplied by 10 is 120. And 7 multiplied by 9 is 63. Obviously, you can use your scientific calculator for it. Now, the sum of all this 35, 80, 110, 120, and 63 gives rise to 408 as the summation xy value. Now, as per the formula, we have calculated the values of every single term that we require. Now, let's plug in all these values in the formula and let's try to find out the correlation coefficient. So, let's plug in the values. We get R equals n value is 5 that we already have calculated multiplied by summation xy. Now, summation xy is nothing but 408. So, let's write that minus the next term is summation x and summation y multiplication. So we have summation x as 42 and summation y as 47. So let's multiply these two. So 42 and 47. The whole divided by under the first square root we have n that is 5 multiplied by summation x square. Now you need to be very careful between summation x square and summation x the whole square. Here it is summation x square. That means the sum of the squared values of x. That is 382. So let's write that 382 minus summation x the whole square. Now we already have found out the value of summation x that is 42. We just have to square it now. So that is 42 the whole square. So this is under the square root. Don't forget it. The whole multiplied by the next square root. Under that comes n that is 5 multiplied by summation y square. Now we have calculated the value of summation y square that is 451. So let's plug in that. We have 451 minus summation y the whole square. Summation y value is 47 the whole square. So we have plugged in all the values. Now we just have to calculate it. So R comes out to be 5 multiplied by 408 comes out to be 2040 minus 42 multiplied by 47 comes out to be 1974. The whole divided by under the square root we are left with 5 multiplied by 382 is nothing but 1910 minus 42 square is 1764. In the next square root we have 5 multiplied by 451 which is nothing but 2255 minus 47 whole square is 2209. Now we are one step ahead. 2040 minus 1974 is nothing but 66. The whole divided by under the first square root 1910 minus 1764 is nothing but 146. Multiplied by under the second square root we have 2255 minus 2209 is nothing but 46. So this boils down to 66 divided by square root of 146 is nothing but 12.083 multiplied by square root of 46 is nothing but 6.7823. Now this further boils down to 66 divided by 12.083 multiplied by 6.7823 is nothing but 81.9505. So this further boils down to 0.8053. So we got our R value as 0.8053. Now you can see that our R value is positive as well as it is close to 1. 0.8 is close to 1. That means we can straight away see that both the variables x and y are having a strong positive correlation. Since it is having a positive value as well as it is having a value which is closer to 1. By the definition, if you remember in the previous video, we already have studied positive correlation. It says that if one variable tends to increase, the other variable also tends to increase. You can see if x is 5, y is 7. If x increases, that means if x goes from 5 to 8, here y is also getting increased, 7 to 10. Similarly, if x goes from 8 to 10, that means x is increasing from 8 to 10. Here y is also increasing from 10 to 11. So here we can simply say that it is positively correlated. Since the increasing first variable is getting impacted to the other variable and the other variable is also increasing. So I hope this particular sum is clear to you all. And with this we come to the end of the video. I hope you understood the Karl Pearson's coefficient of correlation concept with its example. If you guys have any single doubt, then you can straight away put it in the comment section. I'll be happy to solve it. For funny technical memes, follow me on Instagram. For more such videos, do like, share, and subscribe to my channel. Also hit the bell icon and don't forget to follow me on Instagram. Please join me on Telegram. Thanks for watching. Have a good day ahead.